Hi class. Our next example of variation of parameters will again be a second order problem, and this time it'll be a little bit more involved on the integration side. It's number 15, and it's y double prime minus 2y prime plus y equals e to the x over x squared plus x. Once again, what we want to do is to solve the auxiliary equation to find the homogeneous solution. This one happens to be a repeated root case again, but that's just a coincidence. So our homogeneous solution is just going to be c1 e to the x plus c2 x e to the x. Again, I need to declare what I want y1 to be and what I want y2 to be. And again, I'm just going to write it in the same order that I wrote the homogeneous solution. Taking the derivative of y2, I use the product rule and get x e to the x plus e to the x. And so my Wronskian is given by this one times that one, which is e to the 2x times x plus 1 minus x e to the 2x. Simplifying, because I'm going to have to put it inside an integral, I'm actually just going to get e to the 2x. Go ahead and mark where the homogeneous solution is. So now we have our Wronskian, and we're ready to start our variation of parameters technique. And I think I'm going to need a bunch of space, so I'm going to try to mark off sections of the board to save for it. The particular solution is u1, y1 plus u2, y2, just as before. And u1 prime is still negative y2 g over aw. And when I plug that in here, I'm going to get negative x e to the x times e to the x over e to the 2x times x squared plus x. Now this actually simplifies quite a bit. It's negative x over x squared plus x. But this simplifies further. This is just negative 1 over x plus 1. So u1 is negative integral 1 over x plus 1 dx. This is a simple u substitution, u equals the bottom. So what we get is the natural log of x plus 1 plus c. And that's it for u1. My guess is u2 is going to be a little bit more complicated. Okay, well, we'll just start down here. u2 prime is y1 g over aw. And filling out the formula there, we're just going to get e to the x times e to the x over x squared plus x here, and e to the 2x for w. And a is again 1. This simplifies as 1 over x times x plus 1. And now we can see what's going to happen is that u2 is the integral of 1 over x times x plus 1, which is a partial fractions problem. So I'm going to do my partial fractions up here. 1 over x times x plus 1 should be split up into a over x plus b over x plus 1. And remember, the rule for that is that whatever the degree of the polynomial is on the bottom, you just take off 1, so in this case it's a first degree, and this one's a first degree. Take off 1, that's a 0th degree, and write a generic polynomial of that degree. So the generic degree 0 is just some random constant, we call it a. Another different generic degree 0, we'll just call it b. Common denominators, to get equality across the top, we get ax plus a plus bx. And collect terms as a polynomial. So the polynomial on the left is supposed to be the polynomial on the right. That allows us to equate coefficients to solve for a and b. The coefficient of x on the left is 0 because it doesn't show up, and the constant coefficient is 1. On the right, however, the coefficient of x is a plus b, while the constant coefficient is a. This system isn't terrible to solve because we already have one of the solutions, a equals 1. If I plug in a equals 1 here, I should get b equals negative 1. Which means I can split up u2 as the integral of 1 over x minus 1 over x plus 1 dx. So both of these integrals are straightforward. This is the natural log, and that's a u substitution away from the natural log. So just calculating that, we get the natural log of absolute value of x minus log of x plus 1 plus c. And again, these could be different c's of c tilde. It's not going to matter because I'm going to set them equal to 0. So now that we have u1 and u2, we just put yp back together. Yp is e to the x, I'm sorry, u1, so negative log of x plus 1 times e to the x plus u2, which is log x minus log of x plus 1 times x e to the x. And once again, we may be able to simplify it, but don't worry about it. Just leave it like this. Mark out where yp is. I've already marked where yh is. So the general solution is always given by the particular solution plus the homogeneous solution. And that's it.